So hello guys. So now we're gonna describe motion and we're gonna link motion to the idea of forces. Okay. So at the start, early when you learned motion, we said speed is equal to distance over time, or distance is equal to speed times time, or time is equal to distance over speed. These are the three equations you learned in year 7 and 8. This was because acceleration was zero, or acceleration wasn't there. So you consider that the speed is constant. So you could actually just simply input the information and just calculate speed. Now it's different in this case. We have something called acceleration we're gonna go through now. So first of all, let's learn what is instantaneous speed. Instantaneous speed is a speed at a certain instant, which you can see when you drive in a car that shows on the speedometer, okay? And then you've got something called average speed. Now, average speed is different. So let's say that you take a car and you go from Kuwait, okay, to, for example, Bahrain, okay? Now, that is gonna take you about, let's say, about 600 kilometers. Now, through the way when you're going there, you're gonna stop your car for a gas station, you're gonna stop at a police check, and so on. So, no matter what it is, when we say average speed, you just say it's the total distance over total time. So, for example, let's say that it took you 6 hours to reach there. So, that's gonna be 600 kilometers, which is the total distance covered, divided by the total time. So averagely, you're gonna be driving on 100 kilometers per hour. Okay, that's what is average speed. So we don't account for the speed that you went to zero or you stopped and so on. We just take the total distance divided by the total time, and therefore you calculate the average speed. Okay, now let's move to a different thing. Now we're going to talk about acceleration. Now, as you can see, acceleration is the rate of change in velocity. This equation is for those who are studying at Excel, but now I'm talking in Cambridge for Cambridge students. Now we're going to talk about acceleration. Now, as we said, it's the rate of change in velocity, how much the velocity is changing. There are two types. One that is a positive and the other is a negative. As we said, acceleration is a vector. So it can be a positive value, it can be a negative value. So let's say you have an object started at point A with 0 meters per second. It reached 100 meters per second. It did that in a time of 10 seconds. So to calculate the acceleration, it's final velocity minus initial velocity divided by the time. So the final was 100. Initially, it was coming from 0 divided by 10 is going to give you 10 meter per second square. That is the unit for acceleration. Okay, so let's say at point B, the driver decided to decrease his speed to about 50 meters per second. Okay, so let's say that happened in a time of 2 seconds. Let's say 10 seconds as well. Let's keep the time the same. He decreased the speed in 10 seconds. Now, to calculate the acceleration, it's going to be the final velocity, which is 50, coming from a speed of 100, divided by those 10 seconds. So that's going to give you a minus 50 divided by 10, which is minus 5 meter per second square. This is what you call deceleration. It's the rate of decrease in speed. This was the rate of increase in speed or velocity. Okay, so that is the idea of acceleration. Now let's link that to forces, but that's going to be in the upcoming video thing.